and B should be 2. A should be 2.4 and B should be 2. Now 2.4, that's messy, right? Does anybody have a better way of answering that? Making sure my sound is off. Yeah, I like 12 over 5. That's a little bit better because then it's technically 2 2/5, but 12 over 5 is a whole lot nicer. Number 24, but if you were using, were you allowed to use graph table for that? No, you're supposed to be doing conjugates and all that jazz? Oh, to visualize. Ugh. Visualizing's nasty. You can trace. You can hit the trace button and type in x values. You can technically do that. It's a shortcut to the value function. But you could have multiplied by a conjugate, right, guys? If you had to do it by hand. Okay. Number 24. Well, hold on. You wouldn't have had to multiply by the conjugate for 4. You just plug in. Yeah. That's silly. Number 24, final answer is 0, but you had to know your unit circle. Woo! Number 36, final answer is -1, but you had to know that ln and e cancel out because they're inverses of each other, and the -1 pops down. Number 44a, 3. B, 3 halves. C, you guys can see it. I'll give you guys a second. Do you have time to write down all work? No. Do you have time to write down answers? You should. Go straight to the answer. If you have it differently, mark it wrong, put it right. 58 looks an awful lot like a multiply by a conjugate problem. And that's exactly what they did. I would have put parentheses everywhere just to keep myself honest, but if you guys FOILed properly, outer, inner cancel, reduce, 1 over, plug it in, plug it in. Now pause. When did they stop writing limit? Check your work. I don't want to take off points. Don't make it illegal. When did they stop writing limit? Once they were plugging in for the final answer. What technically should have been way back here in the very beginning? You should have plugged in or tried to plug in at the very, very beginning, right? So shouldn't it be a 0 over 0, keep going before you ever start? Didn't we see one yesterday where our brains are going to go to a forever card? And if we don't try to plug in first, we might get it horribly wrong. Because I can promise you a multiple choice answer is going to be there that matches the forever card that didn't apply. You guys know what I'm talking about, right? Yesterday, I asked you like what was easiest to do with all the tricky things. And there was the one that had 1 minus cosine of x all over x as x goes to pi over 2. Always plug in first. But yeah, 0 over 0, keep going, should end up with 1/4. 0 over 0, keep going, simplify the complex fraction, -1/16. Should your work look exactly like theirs? I don't think so. I mean, maybe one of you does it like that. What should your work have been? Multiply top and bottom by x plus 4, and I would have even gone further and also said 4 also. 4 and x plus 4, 4 and x plus 4. Do your distributing. Everything gets nice and pretty. Then you plug in. Remember, the limit stays until you're plugging in. Ooh, 64. Why was it nasty? Is this the one you were talking about, Michael? What one were you guys talking about with the difference quotient? Who was this one? Totally looks like the difference quotient, right? Because it has a little delta x in there. What if you hate delta x? Is there another way? You can replace it with h and not have to use the delta x until, well, even technically, not even until the end, because it goes away eventually anyway. You would have had to FOIL, but if the delta x confused you last night, remember, write the final answer. You don't have time to write all the work right now. Make it an h. And then number 80. Ooh, this one was nasty. I had Lorenzo from period 6 in here yesterday, and he was like, what do you do? Did any of you guys figure out this was a difference of squares? Ooh, so nice if it's a difference of squares. But if you didn't realize it was one, well, life's going to get kind of messy kind of fast. Because you're going to plug in and get 0 over 0, keep going, and not exactly know how to keep going. Now, a few of you guys are like, okay, fine, it tells me it's a difference of squares. Let me show you really quickly. Although we saw it last year when we had to factor quadratics with e to the 2x. You didn't like it then either. Is it just me, or did that not write? Oh, it's white. Okay. Well, that's not what I intended. Okay. Huh. But now it's erased. Anyway, okay, so e to the 2x It's e to the x squared. Why? When you raise a power to a power, you multiply. So x times 2, 2x, can be split up to be e to the x squared. And so if I have e to the 2x minus 1, then I can say, oh, it's a difference of squares. It's a squared minus b squared, which is a plus b, and times a minus b. And then it's like, oh, nice, simplify, simplify. Rewrite the limit until you plug in, done. How many of you guys got 8? Nice. Nice, there were like 5 of you. Good job. But the rest of you guys, it was hard. Does it make sense now? It's a difference of squares. It was hard. All right, I think that was the last one because I see the next homework coming up. So what did we get when you guys were, let's start here. When you guys were talking in your groups, what are some odds that we didn't quite fully? AJ. Oh, let's pause on the evens for a second. Odds? Allie, did you have one? 93. AJ? No? 69. 69, 93. Any other odds that we weren't exactly solid on? Okay, let's start with 69 just because it came first. Then we'll go ahead to 93, and then we'll see if you guys have anything on the evens that you had to mark wrong and you're not quite sure why. So, starting with, just getting a white space. That's not white, that's white. Good. Okay. I apologize not having everything quite ready. We're not in chapter 2, are we? That's BC. If you're wondering why BC is in chapter 2, their chapter 1 is like your chapter P preview. Does that make sense? Just don't feel quite as bad about yourselves. But also, I just heard someone talking the other day. But also, their book goes way faster. If you look at their book compared to yours is super thick and theirs is super thin. Theirs goes really fast, which is okay because they already learned a lot of the stuff. Okay. Sorry, number, Rachel, was 69? Got it. Limit as x goes to 0. This is the one that we started talking about yesterday, and it's like, hey, if you get to homework, you're going to get stuck. Who's able to walk through, talk through how they were able to solve that? But before I take a volunteer, I think we all should have been looking at to solve this one, right? Which we didn't do together yesterday. We just saw it was a problem. Should have been using forever number 3, right? But how? It doesn't match perfectly. How can you use forever number 3? Let me get this back up and then this back up. What'd you do? What'd you know? Good. And was it? Oh, bummer. Okay, then what? Good. Because it understood 1 over 5 according to the limit properties from section 1.2. Is that where we wrote them down? Constants can come out of limits. So then the 1/5 comes out, and Janelle, do I just rewrite the rest? Okay. Then what? Good. So this function will approach 1 as x approaches 0, and that all comes back to right here. Does that make sense? So then once we have that, it was as easy as, ooh, that's not the right one. 1/5 times 1. No more writing of limits, because we took it by using the property. Dun, dun, dun. Dun, dun. Okay. Allie, number 93? Okay. Number 93, was that the last homework problem? Ah, that's a difference quotient too. And some of you remember the difference quotient is the same thing as the definition of the derivative, so that's kind of exciting. But let's go ahead and come on back to me getting white space. Oh, that's fun. You already spotted one? Ah, I'm hitting so many different things. This is such a struggle. Yeah, I'm just going to come over here and close whatever I don't want open. They're entertaining for sure. All right. Yahoo used to be big. MSN used to. Okay. Number 93, what is the difference quotient? You guys should have it memorized. Maybe not memorized, but at least kind of. Wait, pause. Who likes delta x? Who likes h? Huh, all right. So, you could still use delta x, but you can also use, if they give you that delta x formula, you can just go ahead and change it as long as, what did I tell you last year? Yeah. Do something like that. So the function in number 93 that they told us to do the difference quotient to, aka find the derivative of the long way, was f of x equals, it's a nice one, 3x minus 2. Ironically, guess what we're doing in pre-cal right now? The difference quotient. They have no idea what a limit is, no idea what a derivative is, no idea, but they're just practicing function notation. Oh, I erased it because I was supposed to finish it last night. But yesterday, they were practicing function notation. Function notation says, I'm not going to do it like where I write out the different pieces. It's so possessed. But I am going to come up here and I am going to go ahead and say, hey, remember, when you're doing function notation, you have to think about what goes inside the function. Think about those x's as placeholders. Last year we talked about it as like a box that you were filling in. So f of x plus h, you take f of x and say, hey, what am I putting in instead of x? X plus h instead. It was 3 times x minus 2, but it's just saying 3 times input minus 2, and who's the new input? 3 times who? 3 times x plus h minus 2. But then I have minus, who's f of x? Well, 3 times who? 3 times x minus 2. Oh, it's the same thing as, yeah, because that's f of x, that's f of x. All over h. Plug in 0, and every time difference quotient, you will always get 0 over 0. Keep going, and how do you keep going on this one? Factor, ugh. Conjugate, complex fraction. Wait, what are we going to do? Just simplify, combine like terms, and see what happens. And so hopefully after legal simplification, not killing seals, aka not improperly distributing. Not killing seals, not improperly. That's a plus. Distributing. You can go ahead and, if all works out well, everything without an h will cancel out. Everything with an h will be left. Long story short, you end up being able to simplify out all the h's of the numerator. There's only one with the denominator. And what's the limit of any constant? Dun, 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 dun. Pause! If this is the definition of the derivative, couldn't we check it with something because we went ahead in the summer review packet? How could you derive this function the shortcut way? The exponent. What's the exponent of 1? Of x. That 1 comes down. What's 1 times 3? X to the, what happens to the exponent once you bring down the 1? It decreases by 1. What's x to the 0? So we could check it by saying, wait, isn't f prime of x equal to 1 times 3, x to the 1 minus 1, 0, minus, what's the derivative of any constant? What's the slope of any flat line? 0. And x to 0 just goes away, so I get 3. Dun, 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 dun. Anyway, that's just double checking. With that, let's go ahead and put homework away because we're already, well, evens. I apologize. Evens. I apologize. Do we have any questions on evens?
I have a different question.
Go ahead.
Do we have to write the limit L with like that fancy L? Or is that just
No. I do the limit with the cursive L just because it keeps me honest as far as ones and absolute values and L's. I just don't like, that's why I also put like slashes through my 7s, and I also put like slashes through my Z's, and I make little curly Q's with my 2s. You don't have to. I had an alumni from, 8 years ago? Wasn't Mr. Tripoli's class. Oh, it was Miss Becknell's class, the new French teacher. Was it? Yeah, it was her class. There was a guy in that class. She didn't take calculus with me, but there was a guy in that calculus class in college, and the professor did a limit problem and was like, what's wrong? And he raised his hand. He was like, you didn't do a cursive L limit. And he was like, you're cute. And then he kept going. Anyway, so the kid came back, was like, so that's not like an actual thing you have to do? I said, no, it's just notation, my way of. So don't ever like call down a professor for not doing it if you ever have to face it again. And you choose as to whether or not you'll always know that that little whatever you do is an L and only an L. AJ. 58. 44. Let me pull up the answer key just because we have those evens. And maybe I can kind of do that. So on 44, which one do you know? The idea is, even though we're not specifically, like you were thinking we can't stop writing the limit because we haven't put c in, right? Is that kind of what's going on? Even though we're not specifically putting c in, we are plugging in, based on the directions, we are plugging in for the whole thing. So when we plug in 27, we're not just plugging in for f of x, we're plugging in for the limit of. So it's actually because of the substitution. So it's not so much whether or not we plug into c, it's no, the whole limit comes out and 27 goes in. Does that make sense? And it's all based on the given. AJ, what was yours? 58. Anything else besides 58 in the evens? 62. So let's do 58 first. 58, where'd you get stuck, kiddo? Uh-huh. Right. Okay. So let's think about it. A squared. Remember, CalcChat makes jumps, or the solution guide, which is where CalcChat, the odds come from, makes jumps. So your first, what would be square root of x plus 1 squared? X plus 1. So I would say in between for most of us, it would have been wiser for us to go ahead and do something like x plus 1. And then outer plus 2 root, inner minus 2 root, they cancel. And then last, next step you would have simplified. Yeah. Next step you would have simplified. You guys see why they didn't FOIL the bottom, right? Because you definitely need to FOIL the top. That's the whole point, is this radical guy messed me up. I can't factor him. I want to get rid of the radical. Oh, now I can. But why didn't we FOIL the bottom? Because I want to leave him nice and just as he was from the beginning, so that when I make it match, I can simplify by reducing. Yeah, so for multiplying by the conjugate, you always multiply the conjugates themselves. A squared minus b squared, but then you always leave the other one factored out, hoping that they will reduce, which if you did it correctly, it should. Okay, and then the other one, sorry, was 60. Okay, how about that one? Where'd you get stuck? Complex fraction. That's okay. Because they didn't show their work nicely, right? So then if we were to, now I want the white pen. Where is he? He's this one? Yeah. So if you weren't to do their step, because their step took a big old jump, not that it was wrong for someone who'd been doing this for a long time, it wasn't too bad, right? But for those of us that haven't been doing it for a long time and can't mental math complex fractions, it'd be a little bit better if we were to pause. You guys know 0 over 0, keep going, right? Okay. If we multiply by 4 times x plus 4, probably the denominator, ignore that guy, right? Okay, probably that denominator should make sense. You have the 4, the x plus 4. Well, they did some simplifying. What was behind there had the 4 and the x plus 4. But in the numerator, that's where we have to be careful, not kill any seals and properly distribute. AJ, what happens when we take this guy over? If we were to rewrite these two on top of that one, what does it become? Good, but don't forget your parentheses. Because 4 minus, and then as it comes in again, right, for the second distribution, then the 4 is reduced that time, and the x plus 4 is left, but we have that subtraction on the bottom. We have 4x and x plus 4. We haven't finished our plugging in yet. We haven't finished our solving, so we still have our limit. So I would go from here to here. Now, distribute that negative. Negative x, negative 4, 4 minus 4, what happens? Negative x over x, what happens? It reduces. Plug it in, done. All right, with that, kiddos, now go ahead and put away your homework. We did have an opener, but obviously you guys got to say good morning to Mrs. Nichols instead. So maybe we'll do that opener another day. But for right now, let's go ahead and get into section 1.4. Yeah, we can do that piecewise function aside another day. Let's get into section 1.4. I'm going to go ahead and zoom in on this, guys, so that you can draw these sketches. They don't have to be super, super precise. As you notice that there aren't any tick marks as far as the points and how far over, how far up, etc., etc., etc. But I do want you to mark down the C. I do want what's going on at C to be clear. A hole, a jump, a vertical asymptote, a break. I want that to be clear. So let me give you a second to get that started. You guys should be pretty close. This next homework isn't due until Tuesday, but remember Monday is a holiday. So it's kind of just like you're going to have 2 days on it, but you end up having a 3-day weekend. Just be careful. Just be careful. Don't leave it till Labor Day night. That would be a bummer. Tonight's homework is to start. Tomorrow's homework is to finish. Okay, what's going on in each and every one of these? First one, we have a hole, right? At x equals c. What's going on in this one? We have a jump. At x equals c. What's going on in this one? We have a vertical asymptote. At x equals c. How about this one? There is a hole. Can I say with other point? There is a hole, but there's another point. So, well, I'll get to that in a second. Which of these are piecewise functions? Just from your experience, what do you think? Which of these are piecewise functions? Okay, this one for sure. Right? What else? Could be the hole with the other point. This one would be you have x less than c and x greater than or equal to c. 2 different pieces. Does that make sense if I was to brace? You have x less than c and then greater than or equal to. Good morning. Joyce, Kim, Richmond wants you at the end of class. What would this one be, the inequalities? It's not greater than. It's not 2 different pieces on 2 different sides. Doesn't it seem like there's only one function for everything but that? How can we do an inequality for everything but that? Yeah, not equal to, right? So I can say x not equal to c and x equal to c. Those would be my 2 pieces. Something's going on for everything but c, and then something else is going on at c. Any other piecewise functions? One more. Why the asymptote? This looks kind of like a, what basic function does this look kind of like but shifted? 1 over x squared but shifted to the right. But Do vertical asymptotes usually have random points just chilling in them? It's a piecewise. And this piecewise, what would it look like? Is it this case? One piece on the left, one piece on the right, a hole is on one of them? Is it this one? Everything but, and then what's going on at? Yeah. At x equals, it made a point. And then everywhere else, they have what looks to be like a 1 over x squared type of function. Why do I say type? Well, it could be 2 over x squared, it could be 10 over x squared, it could be technically something like 10 over quantity x minus c squared. Anyway, can't be negative, because if it was negative, what would happen to my little swoop? There it is, right? So it can't be a negative one. But okay, so we have 3 different piecewise functions with discontinuities, and then we have 1 non-piecewise function with a discontinuity. And maybe some of you guys realize that vertical asymptotes don't always have to have points. So we could have had a non-piecewise function vertical asymptote discontinuity without a piecewise also. So what's going on in all 4 of these? What am I trying to get you to see? I'm going to go ahead and zoom in on the definition, and then we're going to take it to compare with up above and say, okay, what is enough to cause a discontinuity? There are 4 different types up there. What's enough to cause a discontinuity? These 4 are discontinuous, but in very different ways. Let me give you a second to write down the definition of continuous, which in the back, I put a quick little underneath our section. The major topic of this entire section is the definition of continuous. Knowing what it is and how to use it and how to prove with it. A function is continuous at x equals c if the following 3, all 3 conditions are met or satisfied. You can put met if you want instead of satisfied, if that's easier for you to think about. If the following 3 conditions are met or satisfied. 1, f of c is defined. At an x equals c, there is a point. There is an existing y value. F of c is defined. At c, there is a point. Number 2, the limit. Wait a minute, that's not proper limit notation, is it? No. What am I missing on number 2 and 3? Yeah. To keep it in my nice little font, I didn't want to go and make an equation and make it look nasty. So the limit as, I need you guys to add this, as x approaches c. As x approaches c. Add in the little notation, limit as x approaches c if f of x exists. The point has to be there, the limit has to work, and the limit has to agree with the point. If you want to put it in like simple language, number 1, the point has to exist at a c. Number 2, the limit has to exist as you come towards c. And then number 3, the approach has to equal the at. They have to be the same, and if they're not, somehow the thing's broken. Somehow the thing is broken. Somehow there's a discontinuity. Now let's talk about this. For a limit to exist, technically, what needs to be true? How many sides need to work? Yeah, 2 sides, they need to both agree. So another way of putting that, kind of another way of putting both of these, is to say, kind of saying all 3. The limit, as x approaches c from below, f of x, is equal to f of c, is equal to the limit, as x approaches c from above, f of x. Technically, as long as the limits exist and are a constant, technically all 3 of these can be met. That's a nasty brace. I don't do so well when I have to write backwards. Oh, what? No. Stop. It's a little better, except it freaked out on me. All 3 of those can be met in that one statement. The limit as x approaches c from below f of x must equal f of c, must equal the limit as x approaches c from above of f of x, as long as f of c equals a constant. If f of c equals like infinity or d and e, I'm in big trouble. Big, 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 big trouble. So as long as f of c equals an actual limit, an actual constant, if that agrees with that, we're good. A function is continuous. This is like the step 1, step 2, step 3. This is kind of like the, hey, let's put it all together in one statement. At the very bottom, if any of the above conditions fail, then a function has a discontinuity at c. What kind of discontinuity? I don't know. It depends on what's wrong. Depends on which one fails. So let's go back and peek at those 4 graphs up above and figure out where they failed, because they did fail somewhere. They each have discontinuities. But where did they fail? For the first one, the whole at x equals c, where does it fail? Does it fail with condition 1, condition 2, or condition 3? Condition 1. How come? The limit exists. The limit is fine, but who doesn't exist? F of c. Go to c. Where's the y value? Nowhere. So therefore, this one fails. Whenever you have a hole at c, it's failing condition number 1. How about the second one? The jump at x equals c. What's it failing? The second one. Why doesn't it fail the first one? Go to c. Is there a point? Yes. Oh, it doesn't fail the first one. It fails the second one because do the one-sided limits agree? Does the limit exist? Do they agree? No. So since they don't agree, the limit doesn't exist. That would be a D&E limit. How about number 3, the vertical asymptote at x equals c? What does it fail? If the point wasn't there, where would it fail? If the point wasn't there. The first one, yeah. But since the point is there, there's a place, there's a y value. So what doesn't work? You can kind of say 2 and 3. Why? Does the limit exist? We would say yes, it equals infinity, but is it a constant? No. So does the limit exist and equal a constant? No. But you guys can also see, well, and the limit doesn't equal the point. They're 2 very different things. But the fact that the limit is infinity would also make it fail. Vertical asymptote, oh, there's a discontinuity. But the point makes it even clearer because it doesn't even agree with the point that is there. So technically it does fail 2 because the limit is not a constant. But then it also fails 3, they don't agree. How about this last one? Does it fail 1? No, there's a point. Does it fail 2? Confidence. Come on. No, because aren't the guys approaching the same place? Okay, limit exists. Check. But does it pass 3? No, because do they agree? Where the guys are headed, is that really where breakfast is being served? No. This fails 3. Any type of discontinuity that you might come up against is going to fail somewhere. Sometimes it's going to fail like all 3. Sometimes it's going to fail 1 or 2 of them. All you need, look down here, all you need, if any of the above, all you need is 1 failure. 1 failure and there's a discontinuity at. Could be a hole, could be a vertical asymptote, could be a jump, could look many different ways, but all you need is 1. So, why am I saying or using this definition so much? Why is it one of the big topics on the backboard? Because it's going to show up again and again and again and again. Ooh, and what am I putting around it? A yellow box. And whenever a yellow box comes up, what's it supposed to be? Forever card. So this is forever number 4, but every forever needs a title. So what's his title? The definition of continuous. Not just continuous, because some of you guys are like, no jumps or breaks. Ha ha! That's a description. Definition. Get out of here. I'll see you guys later. Thanks for your patience with me getting in late. Happy Thursday. Hope it goes all right. I hope Mr. Jones has grace. Bye, Grace.
We're gonna be taking a really quick thing.
Oh, no.
Oh.